Hey everybody, amprepairguy.com, 203-892-4119. So, I have the motivation to work on the multiband amp, 160 through 15 meters, 12 kilowatt CCS, no roller inductor, uses progressively shorting rotary switches. There's a big difference between an amp that is brick on key versus a SSB, intermittent duty cycle. People say, why are you doing 12 kilowatts? Because this tube costs less than an 8877. I already have it. I already have the socket, the transformer, all the transformers, plate transformer, everything. I already had most of everything you see here and some, so why not? I'm going to run it at the legal limit, and this thing should last forever, So with all the digital modes nowadays, the amps that are made commercially, they just can't take it. Whether it's tube or solid state, you have to derate them by half or more. And I see people with undersized roller inductors. They don't clean them. They overheat them. They try to do AM or high duty cycle mode. They fail. So no worries with the switching in this amp. This is literally the output rotary switch out of a Kenwood TL922. It's doing the input switching, and I'll show you the output rotary switch in a second. So I learned some stuff on the 6000 6-meter amp. I'm going to do a lot of the same what I did in that with and incorporate it into this, like the filament test lead points. I'll mount them in the back same way. I'll show that tonight when I'm done. I don't think I'm going to use that. Well, I'm not going to use that protection board. It's not needed. It just adds complexity and more likelihood there could be a problem at some point. I might put a grid overload board in it, possibly, because I'll have this operating. I might set it up so I can operate it remote. So I want it to shut down if there's ever an issue if I'm not around it. Unless it's going to be in a different room anyway, I won't hear it. So there's an amp funnel connector that mounts here. And any of the connections that need to go from the top to the bottom will go through that. When it comes to the rectified voltage that feeds the input TR relay and the output TR relays, and I'll have the pressure interlock up here. Unlike the other one where it was in the bottom, and the wires for that, it'll loop from the bottom up through that and then back down to a relay. So if there's no blower on, it'll shut everything down. The B positive and the B negative will come up through cabling through a corrugated tube, flexible tube. I'll show that in a second. And they'll have an Alden connector on the other end with an interlock where that connects, where the plate connects to the bottom cabinet. So I want to use these instead of a meter on the front. Fluke is way more accurate than an analog meter. Could put a digital meter on the front, but it won't match the other metering. I decided I'm pretty sure I'm not going to use the meters that I have or the panel I have. I'm going to have a custom panel made, and I'll have all the meters made. It's not cheap, but I'm saving so much money on everything else. I'm going to splurge on the front panel. I'm going to have a lot into it. They're not cheap to have them custom made and all the backing plates done nice. I just want this to look really, really nice, so these things are temporary. If you haven't watched my other videos, these isolators are just to make it easier on me. So the plate and the load, vacuum variables, I'm going to mount it. Well, you'll see how I'll mount them, but they'll be standing vertically. And I'm going to have a right angle drive coming out the front panel on each side. And this is the input rotary switch shaft. I'll have the output rotary switch shaft. Unfortunately, the degree of indent, I think it's called, is different, so I can't gang them together. I might see about a coupler that compensates for that. My friend Jim told me about that, so I'll see if that's possible. But as far as the plate and the load adjustments, I plan on lining them up with the input adjustments, and I'll have to use a sprocket and chain drive to go to each one. I want everything to look just really nice. This is going to be my personal box. I plan on keeping this forever. So, okay, so that's that. I will show you the load vacuum variable. 35 to 3000 puff, 5 kV, high pot's higher than that, but I'm going to have a spark gap between the load side and ground, and also a spark gap between the plate side and ground. That's 15 to 750, 15 kV slash 9 kV. So I'm going to mount those. I went and got the hardware. The holes are only, I think they were like ½ inch deep, so I got both. I didn't want to only catch a couple threads, so I went with the longer ones. I'll have to double washer and then put a split washer on some of them. Well, split washer also on all of them, but some will need a double washer. Where it's thicker, I won't need it. You know, the double washer. So I have all the hardware, I have the coils. The coils aren't going in tonight, but you could see 160, and it gets progressively larger as you go up in frequency. So 1/4 inch, that's 3/8, and this is ½ inch. I already had this. I have a box full of silver plated coils, but I had to make those and I have to gap them and all that. That's not happening tonight. That'll happen next. So here's the rotary switch. I lost one of the screws. I have another one of these, a spare one in the other room, so I'll steal one. First I'll look for the screw, see if it's over there somewhere on the side of the room. But so this is a modified switch. I did this years and years and years ago. Started off as it's a multi-tech switch, progressively shorting. It gives me 160 through 15. Fully opens 116, then it progressively shorts. Started off as a 40 amp switch. I doubled up on the contacts and made it an 80 amp switch. Someone else did the same thing, but I did this over, I think it's been over 10 years. I got a couple of these from a guy who passed away, and I had to cut the shaft. That was fun. But I bought the detent assembly from Multi-Tech. Really nice people there. Okay, so I'm going to show you the bottom cabinet really quick. The bottom panel, the bottom cover to this. This is really thick material. That's why I love this. I think it's like 1/8 inch thick. And this is conductive, this coating. Okay, so I'm going to show you the bottom compartment, the bottom panel, and the cable, where the cable goes through the B positive and B negative, the corrugated material, and also the rack cabinet. This is going to literally look like a little mini refrigerator. Keep in mind the plate transformers will go in another cabin, a small cabinet, and I'll have another corrugated cable assembly to connect those two, and then I'll use 250 amp supercon connectors for the line that connects to the primary. So, okay, so I'm getting ahead of myself. I'll go show you that stuff, and then I'll go on from there. See you soon. Okay, so here's the rolling cart. The RF deck connects to these sliders, slides in and out. Blower hangs from the cover of this, and it has this material to seal, basically the same as the other one. The grill in the front for the air to go through, and it has solid panels go on the sides, in the front. So this thing, and then it's on caster, so it literally looks like a mini fridge. It's not that deep either. So here's the corrugated, sorry, I have a lot of stuff. So here's the corrugated assembly. Got the Alden high voltage connector. This one's broken, but I have more. So this attaches to the bottom cabinet, and this attaches to the top cabinet. You have the B positive, B negative, super safe. Here's a bottom cabinet. This is what this cabinet looks like. Here's another one. So that square connects to here, and there's a little interlock switch. That's what the other connector looks like. That's up on the RF deck. That will be installed on the RF deck. And cable like this. See the connector. So I'll install the supercon connectors for the line where it'll connect to the breaker, and then 2 supercon 250 amp ones that'll connect to the plate supply, and then I'll have a cable like this for the AC coming from the plate supply into the cabinet. Okay, so one other thing, I want to show you the bottom. Be right back, I have to find it. But here's a box of coils. There's so much stuff. I'll be using 100 amp mercury contactors for line switching. And a lot of ferrite rods, type 43, all what are they, 5/8 inch. Just a lot of stuff I'll be getting rid of in January. Just have too much stuff. And there's another cabinet. I have another one, and oh man, just lots and lots of stuff. Okay, be right back. Okay, so here's one of the bottoms. Talk about a lot of screws, huh? I'll take that off so I don't impede airflow, but you can see the right angle bend on the front, which the front panel screws into. And here's a stock front panel. There's a lot of parts. Here's another stock front panel. There's the blower I'll be using, EVM PAP, same as the other one. So here's another RF deck. I just have lots of stuff. The rear panel. So this is what the rear panel looks like with the high voltage cable attached to it. So yeah, I've been going through stuff, and sorry it's such a mess. A couple parts 922s. So no, I cannot sell parts, so please don't ask, because I need these. People have asked. I'm sorry, but I do need the parts for the amplifiers I work on. Here are two of my washer meters. I have another one over there. These are great. So anyway, I'm going to get to work, and I will see you guys soon, so stay tuned. Done for the night. Vacuum variable capacitors are mounted. Band switch is mounted. Coils will go in here. One will go vertical. So the front, I redid the detent switch because I moved the common to the other side. Look at this. Right angle drives. Shaft will go right through here. The sprocket. Chain drive, so the plate load match these locations. Same thing. Right angle drive. Go through there. Chokes, resistor, 0.01 caps, and the connection points like the other amp. So it's coming along. So stay tuned. Lots more to come. I'm going to bed. It's late. Worked all day and worked on this. It's 12:30 at night. So thanks for watching. AmpRepairGuy.com, 203-892-4119. 73s to everybody.